Okay, so this is question 8, 2024 Higher Level Maths Leaving Cert Deferred Paper 2. Henrik has a farm. The diagram below shows one of Henrik's fields. It is in the shape of a triangle ABC. AC is 59, AB is 47 meters, and the angle CAB is 28 degrees as shown. Find the area of the field correct to the nearest meters squared. So this is just simply a formula. So the area of a triangle, is going to be half AB sine C. This is where you have two sides and the enclosed angle. So we have this side here, we have this side here, and the angle enclosed by the two sides. So we can use this formula. So it's half times 59 times 47 times the sine of the angle, which is 28 degrees. So when you do all of that, you get, correct to the nearest square meter, 651 meters squared, correct to the nearest meter squared. Okay, let's have a look at part 2 of part A. Work out the length of the side BC correct to 2 decimal places. So we've got to work out this side here. So again, we have two sides, we have an enclosed angle, so we can use the cosine rule to find the side BC. So it'll give us BC squared is equal to 59 squared plus 47 squared minus twice the two sides multiplied, 59 times 47, times the cos of the angle enclosed, which is 28 degrees. So when you do all of that, you get 793.17265. So remember, this is BC squared. We need BC, so we've got to square root both sides. When you square root this here and round it to 2 decimal places, you get 28.16 meters. Okay, let's have a look at part B. Henrik has two balers, a square baler and a round baler. These are machines that pick up straw from a field and make it into bales. Henrik's square baler travels at an average speed of 8 kilometers per hour while it is baling. For one of his fields, the baler travels 4,800 meters while it is baling. Work out how many minutes this will take. Okay, so this is just a simple speed, distance, time problem. We know that speed is distance over time. So we're looking for how many minutes, so we're looking for time. So time is distance over speed. So what are we given? We're given a distance of 4,800 meters and we were given a speed of 8 kilometers per hour. So we can see we've got mixed units here. We've got meters and we've got kilometers. So what I'm going to do is change this to kilometers. So there are 1,000 meters in a kilometer, so I'm going to divide by 1,000. So that's 4.8 kilometers. So let's put that into our formula. We have a distance of 4.8. We have a speed of 8. When you do that, you get a time of 0.6. And remember, we're talking about kilometers per hour here, so this is in hours. The question asks for the number of minutes that this will take. So we've got to multiply that by 60, and that will give us 36 minutes. Okay, so fairly straightforward question. Okay, let's look at part C. The baler makes bales in the shape of a rectangular solid. A bale has volume 0.415 meters cubed, correct to 3 decimal places. The ratio of the dimensions of this bale is height, width, length 2:3:5. Find the dimensions of this bale. Give each value correct to the nearest centimeter. Okay, so let's just draw a bale, a rectangular solid. Let's say it looks like this. We're told that the height, width, length is in the ratio 2:3:5. Well, let's call the height x. So that's the 2 part of the ratio. The width is 3, so let's take this here as being the width, and that's going to be 1.5 times x. If you multiply 2 by 1.5, you'll get 3. So this is going to be 1.5x, and then 5 is 2.5 times 2, so that's the length, so this is going to be 2.5 times x. Now when you multiply these three together, you get 0.415 meters cubed. So let's do that. We've got 1.5x multiplied by 2.5x multiplied by x, and that should give us 0.415 meters cubed. Now when you multiply 1.5 by 2.5 by 1, you get 3.75, and then x times x times x cubed is equal to 0.415. Divide both sides by 3.75, that'll give us x cubed is equal to 83 over 750. And then finally cube root both sides. So if you cube root the left hand side, you get x. Cube root 83 over 750, you'll get 0.4801080004. So the question here is to find the dimensions of the bale. So we know what this is. All we got to do is multiply it by 1.5 and 2.5 to give us the other two dimensions. Now the question asks us to give our answer to the nearest centimetre. So remember, this is meters here. So there are 100 centimeters in a meter, so this would be 48 centimeters. So we've got to multiply this by 1.5, so 1.5x is equal to 0.720162006, and that will be roughly 72 centimeters to the nearest centimeter. We need to multiply this by 2.5x by 2.5. So 2.5 of x is 1.20027001, and that is 120 centimeters to the nearest centimeter. So our answers are 48 centimeters, 72 centimeters, and 120 centimeters. So this is part D. Hendrik's round baler makes bales in the shape of a cylinder. The height of each cylinder is equal to its diameter. So I have here 2r as the height and r as the radius, because this would be 2r from here to here, and that's the same as the height. So the radius then is r and the height is 2r. You could also take the height as being h and the radius as being half h and work that method. That should work as well, but that would introduce fractions here. We're not dealing with fractions, so it should be a little bit easier. So we're told that the volume of the cylindrical bale is 2.780 meters cubed, correct to 3 decimal places. Work out the radius of the cylindrical bale. Give your answer in meters, correct to the nearest centimeter. So the volume of a cylinder is pi r squared h. The volume of our cylinder is 2.780. That's equal to pi times the radius, which is r, which we've got to square. The height is twice r, and let's just simplify that. We've got 2.780 is equal to, I'll bring the 2 out here, pi r squared times r is r cubed. So what I'm going to do now is just divide both sides by 2 pi. So r cubed will be 2.780 divided by 2 pi, which is 0.4424507418. Get the cube root of both sides. So on the left hand side you'll get 0.76200 and so on. Now it says here, give the answer in meters, correct to the nearest centimeter. So this is in meters, so we've got to change that to centimeters. So that's going to be 76.2 centimeters, and correct to the nearest centimeter, it's going to be 76 centimeters. Okay, let's look at part E, the last part of this question. Hendrik is tiling his patio. The tiles are square with a design made of circles. The design consists of a large circle inscribed inside a square tile. There are 4 smaller circles of equal size inside the large circle. The centers of these 4 circles form a square, and each small circle touches 2 other small circles and the large circle, as shown in the diagram below. The radius of the small circle is 1 centimeter. Work out the area of the square tile, the large square in the diagram below. Give your answer in that form there, where a, b and c are integers. Okay, so we need to find the area of this square. So what I want to do is find this length here, or this length here, in other words, the same thing. So that length there is actually the diameter of the big circle. So what I'm going to do is look at I can look at the diameter from here to here, but I'm going to look at the diameter from here down to here first, because if I can find this distance here, that's the diagonal of the square, all I've got to do is add 1 centimeter and add 1 centimeter, and that will give me the diameter of the big circle, because the radius of the small circle here is just 1 centimeter. So what I've got to do first is find this diagonal here. Now I can do that by using Pythagoras' theorem, I'm thinking, because this distance here is 2 centimeters. This distance here is 1 centimeter, 2 centimeters as well. So I have 2 and 2 here. Do Pythagoras' theorem to give me this diagonal here. Add 2 centimeters, this one and this one here, and that will give me the diameter of the large circle, which is the same as the length and width of the square. So let's do all of that. So first thing I'm going to do is find the length of the diagonal of the small square. I know I have a square like this. I know that this is 2 centimeters and this is 2 centimeters here. So I'm going to find this here. I'm going to call it x, let's say. So you got 2 squared plus 2 squared is equal to x squared using Pythagoras' theorem. So x squared is equal to 4 and 4, 8. So the square root of 8 is 2 root 2. So now I know that this distance here, the distance from here to here, is 2 root 2. I know that this distance here is 1 centimeter, and I know that this distance here is 1 centimeter as well. So I can now find the diameter of the large circle. That's equal to 2 root 2 plus 2 centimeters. That is also equal to the length and width of the square. So the area of the square, the large square, is equal to 2 root 2 plus 2 times 2 root 2 plus 2, length times width in other words. So all I got to do is multiply all this out. Well, 2 root 2 times 2 root 2, 2 2s are 4, root 2 times root 2 is 2, 2 4s 8, plus 2 root 2 times 2 is 4 root 2, 2 times 2 root 2, 4 root 2, and 2 times 2, 4. So what I end up with is 8 plus 4, 12, 4 root 2 plus 4 root 2, 8 root 2. And this is in centimeters squared. Now we were asked to write our answer in the form a plus b root c, where a, b and c are integers. A plus b root c. So we've got a plus b root c. 2, 8 and 12 are integers, and that's it. That's it for this question.